Motorcycle sales in Malaysia starting in 2018 increases consistently by 10.9%. A total of 521,230 units of motorcycles were sold in 2019. Estimate the number of motorcycles sold in Malaysia from 2018 to 2025. Now, when you see increase by percentage, it is a GP, right? 2019 to starting is 2018. So we list down the year. At the year 2019, 521,230 units sold, and then we were given starting 2018 increase consistently by 10.9%. So we can use the GP to find the number of motorcycles sold in the year 2018 to 2025. But before that, we need to find the first term. The first term can be found by using a concept of GP. So let's say from the first term, it will increase 10.9%. From the second to third term, it will increase 10.9%. Now, because it's increased by percentage, so we will use the concept of GP percentage. T1 is the first term, and T2 is 521,230, and T3 is the one that we need to figure out. Now we need to sum up from 2018 to 2025, estimate the number of motorcycle. So in this case, now let's find the A first. Now we are having 10.9%. So the common ratio 10.9%. It doesn't mean it increased by 10.9. The common ratio is not 10.9. It must be 10.9% per 100 plus 1. So the common ratio is 1.109. Alright, so I'm going to show you the first term. So we will use a concept of second term over the first term is equal to the common ratio, which is 1.109. Now, so the X, or we call it the first term, can be found by take 521,230 divided by 1.109. So we will get the first term, which is A. We can label as A. If we press a calculator, we will get the first term is 470,000. So you can actually use a percentage to find the first term, right? It's the same. You can use a concept of common ratio to find, but make sure you understand that you have to plus with the 1. So after we got the first term, then we can sum up from the first term to the year 2025. Now I'm showing you the other way to find the first term because some of you might be a bit confused. There's another alternative method is we would take, because it's increased by 10%, so that means at the year 2019 it should be 110.9%. 100% plus 10.9%. So 110.9% is equivalent to 521,230. Hence, the original 100% is a first term, right? Before it increased. So if we find 100%, we will get the first term, right? So we will take 100 times the 521,230 divided by 110.9. So we'll get the same, 470,000. So you can use percentage to calculate to get the A, then you will have a better understanding. So that means from the year 2018, the unit of motorcycle is 470,000. That is the first term. From 2018 to 2015, if you minus 25 minus 18, you will get 7. In fact, n is not 7, n is equivalent to 8. You list down, then you can see 2018, 19, 20, 21, 22, 23, 24, 25. So because it's inclusive of 2018 and 2015, so there are 8 terms. So we can use a GP formula because the R is more than 1. So it's A R n minus 1 over R minus 1, right? So the R, of course, is 1.109 and the n is power 8 minus 1. Minus 1 is below the 8. So over R minus 1, which is 1.109 minus 1. So if you press your calculator carefully, you will get the answer is 5553678. Or maybe you can give the answer 5553679 is accepted. Alright, so be very careful when you use GP. When it's increased, the amount become bigger, the R is always more than 1. Alright, so the R is T2 over T1. So we can actually double check our R common ratio. We can take the 521,230 over 470,000. We'll get 1.109. So common ratio is telling us that the quantity is increasing if it's more than 1. So it's 1.109. Now we are going to proceed to the part B, right? Okay, now I'm going to show you a basic concept about the common ratio. Is actually you have to plus with 100%. 10.9% you have to plus with 100% and write as 1.109. Okay, so if you use a percentage, 10.9, you just plus 100. So it becomes 110.9%. So you convert to 1.109, the same. Right, so we have solved the part A. Now we go to part B. Alright, the part A, you write the common ratio in 1.109 and the first term 470,000, you get 1 mark. And you use a S8 sum for the first 8 term by using the formula Sn equal to A Rn minus 1 over R minus 1 because the R is more than 1. So the answer you will get 1 mark. Now let's move on to question B. If the Yamaha company managed to dominate 36% of the market in 2021 to 2025, estimate the number of motorcycles successfully sold by the company from the year 2018 to 2019, 2020, 2021, 2022, 2023, 2024, and 2025. So as you can see, we have the year from 2021 to 2025, which is representing 36% of the market value. So that means we will take sum for the first 8 term minus sum for the first 3 term. In fact, sum for the first 8 term we actually calculated already. We got the answer, and sum for the first 3 term can be obtained by using A R power 3 minus 1 over R minus 1, and the R remain the same. So now we can solve the sum for the first three terms, which is 1569274. It means that the sum from 2021 to 2025 can be obtained by use sum for the first 8 terms minus sum for the first 3 terms. So we will get the answer, which is the difference of 555368 minus 1569274. So the answer is 3984. Let's double check again. 40. So 398404. This is the unit that actually dominate 36% of the market in 2021. So we are going to take 36% times with the 398404 because the sales is representing 36% of the market in 2021 to 2025. So by using 36% times with the units sold from 2021 to 2025, we will get the number of motorcycles successfully sold by the company. 1434386 is number of motorcycles successfully sold by the company in 2021 to 2025. Now let's see if we use 5553679 minus 1569274. There's a little bit different in terms of the number, so your answer will be slightly different, but end up you get this answer also, right? So let's see how the marks being allocated to you. If you take sum for the first 8 terms minus sum for the first 3 terms, so you show the step how you minus. You are using 5553678 minus sum for the first 3 terms, which is equivalent to the 36% of the market value. You times the 36%, you will get the answer which is shown above. So that's all my sharing for question number 9. Till then, bye bye and have a nice day.